Welcome to Pratham Science Academy classes, and in this video we are going to solve set 3 of 2023. This is the set 3 of the series EFIGH1, and this is the set 3 and subset 1. So let's quickly move on to the section A. The section A comprises of multiple choice questions of marks 1 marks each. And in section A, there are 1 to 18 are MCQs, and 19 and 20 will be the assertion and reasoning based questions of 1 marks each. So for the first question, it's given that a matrix is given, and it's given that it's a symmetric matrix. So for question number 1, our matrix is A is equal to 1, 4, X, Z, 2, Y, minus 3, minus 1, and 3. This is our square matrix of order 3. And it's given that A is symmetric. So bisymmetric means that this matrix is equal, A is equal to the transpose of A. So A is 1, 4, X, and Z is 2, its second row is Z 2 Y minus 3 minus 1 3. So this is A, and the transpose of A, we have to change the rows into columns. So this is 1 Z minus 3, 4, 2 minus 1, and X Y 3. Now matrix A in its transpose, these two matrices are equal, so that means their corresponding angles are equal. And if we compare them, so X is equal to minus 3, X is equal to minus 3, and Y is equal to negative 1, and Z is equal to 4. But in the question is asked to find the sum of these values. So X plus Y plus Z is equal to negative 3, negative 1 plus 4, which is equal to 0. So correct option for this option D. And now let's move on to question number 2. Okay, so for we are on question number 2 of section A, and it's given that the product of A and adjoint A is given. So the product of A and adjoint A is given, and we have to find the value of determinant of A plus determinant of adjoint A. So now A into adjoint A is given, which is 3, 0, 0, 0, 3, 0, 0, 0, 3. Okay. And this can be written as, if we take 3 common, so this gives me 1, 0, 0, 0, 1, 0, 0, 0, 1. So A into adjoint A is actually 3, and this is identity matrix of order 3. So this is 3 into I. So we have got that the product of A into adjoint A is 3 times the identity matrix. Now A into adjoint A, this A into adjoint A is equal to determinant of A into identity matrix, and this is equal to 3 into I. So this gets cancelled, and now determinant of A is equal to 3. So we have got the value of determinant of A. Let's find out what is asked in the question. So it's det A plus determinant of adjoint A. Now det A is 3, and adjoint A, we know that adjoint of determinant of adjoint A is equal to that A raised power n minus 1, where n is the order of matrix. So this is order of matrix, and order of the matrix is 3. So this is determinant A raised power n minus 1, which is 3 minus 1, and this is 3 plus value of determinant is that A is 3, 3 minus 1 is 3 square. So this is 3 plus 3 square is 9, which is equal to 12. And our correct option is option A. Let's move on to the next one. Okay, for question number 3, it's given that A and B are skew symmetric matrices of same order. So A and B are, these are skew symmetric matrices of same order. So A and B are skew symmetric matrices. That means A transpose is equal to negative of A and B transpose is equal to negative of B. So AB is symmetric. So AB is symmetric. We know that AB is symmetric when AB transpose should be equal to AB. So this should be the condition. Now let's try to find out AB transpose. So AB transpose is equal to B transpose into A transpose, and B transpose is negative B. A transpose is negative A, that is equal to BA. So AB transpose is equal to BA, and we know that AB transpose should be equal to AB for AB to be symmetric. So that means instead of BA, it should be AB. So BA should be equal to AB. So when BA is equal to AB, then AB transpose is equal to AB, and then AB is symmetric. So the condition here is AB is equal to BA. Let's move on to question number 4. So correct option for this is option C. And for question number 4. Okay, for question number 4, we have to find the value of x, and value of x should lie between 0 to pi by 2. And the condition is A plus A transpose. So A plus A transpose is equal to root 3 into identity matrix. So A is cos x, sine x, negative sine x, and cos x. And the value of A transpose is cos x, negative sine x, and sine x into cos x. So this is A and its transpose. That is equal to root 3 into identity matrix. So identity matrix should be of order 2. It's 1, 0, 0, 1. And if we add cos x plus cos x is 2 times cos x, sin x minus sin x is 0, minus sin x plus sin x is 0. Cos x plus cos x is 2 cos x, which is equal to root 3, 0, 0, and root 3. Okay, if we compare these matrices, so 2 cos x is equal to root 3 and 2 cos x is equal to root 3, that gives cos x is equal to root 3 by 2, and we know that root 3 value of cos of pi by 6 is root 3 by 2. So cos x is equal to cos pi by 6. So x is equal to pi by 6, and this pi by 6 is 30, which is between 0 to pi by 2. So our answer is pi by 6. So the correct option is option B. And let's move on to question number 5. Okay, for question number 5, it's given that the area of the triangle with vertices x1, y1, x2, y2, and x3, y3. We know that the area of the triangle is given by plus minus the area plus minus half of the determinant of x1, x2, x3, y1, y2, y3, and 1, 1, and 1. But we don't have any of the options here, so let me shift this to this side, which gives me plus minus 2 into area. So this is, let's say, A. This is A, and now it's x1, x2, x3, y1, y2, y3, and 1, 1, and 1 determined. And this matches with the option B. So option B is the correct answer for question number 5. Let's move on to question number 6. Okay, for question number 6, we have to find the integration of 2 raised power x plus 2. So for question number 6, let's say our integral is 2 in 2 raised power x raised power 2 into dx. Now this is of the form integration of a raised power x into dx, which is a raised power x upon log a. Okay, so if we use this formula here, so this is the differentiation is a raised power x, which is 2 raised power x plus 2 by log of a, which is log 2. And because instead of x plus 2, we have instead of x, we have x plus 2. So we are going to multiply this with the differentiation of x plus 2. So this is 2 raised power x plus 2 log a into differentiation of x plus 2 plus c. So this is now 2 raised power x plus 2 into upon log 2, and differentiation of x is 1, differentiation of 2 is 0. So this is 1, and this matches with the option C. So C is the correct option for this. And here we have used the formula integration of a raised power x into dx, which is a raised power x upon log a plus c. So x here, instead of x, we have x plus 2. So we have multiplied this with the differentiation of x plus 2, which gives us 1. And the correct answer is option C. Let's move on to question number 7. Okay, for question number 7, we have to find the integration of, this is question number 7, and we have to find the integration of 2 cos 2x minus 1 upon 1 plus 2 sine of x into dx. Now, let's try to simplify what's within the integration, and for that, what should be the value of cos 2x, and we know that the cos 2x has different variations, so it's 2 cos square x minus 1, and then another one is 1 minus 2 sine square x, because we have sine x in the denominator. So let's try to use this. So this is now integration of 2, instead of cos x, it's 1 minus 2. We are going to use this. So this is 1 minus 2 sine square x minus 1 upon 1 plus 2 sine x into dx. So this is 2 minus 4 sine square x minus 1 upon 1 plus 2 sine of x into dx. Now 2 minus 1 is 1, and it's 4 sine square x upon 1 plus 2 sine of x into dx. Okay, so 1 is 1 square, and 4 sine square x can be written as 2 sine x the whole square, which is a square minus b square, and a square minus b square is a plus b into a minus b. Okay, this gets cancelled. So we are left with integration of 1 minus 2 sine x into dx. Now integration of 1 is x, 2 is constant, integration of sine x is negative cos x, and don't forget to add the integral constant at the end. So this is x plus 2 into cos x plus c. This is the integration, and this matches with option B. So option B is the correct answer. And let's move on to question number 8. Again, for question number 8, we have to find the solution of the differential equation. So this is question number 8, and it's dx upon x plus dy upon y is equal to 0. So let's try to separate the variables and now integrating on both sides. So integration of 1 by x is log x, and integration of minus 1 by y is negative log y. And when all the values are in log, we also take the constant as log. So let me shift this to the left hand side. This is log x plus log y, which is equal to log c. And this is log xy. Log a plus b is log ab and log c. So if logs are equal, then that means the values are equal. So xy is equal to c. And our option is option C for question number 8. Let's move on to question number 9. Okay, for question number 9, we have to find the product of the order and degree of the differential equation. So for question number 9, our differential equation is d square y upon dx square into sine y plus dy by dx the whole cube into cos y is equal to root y. Okay, now here the order is the maximum number of times this differential equation has been differentiated, which is 2. And the degree is the power of the highest order derivative. So highest order derivative is 2 and its power is 1. So it's 1. And we have to find the product of order and degree. So the product of order and degree, order is 2, degree is 1, which is equal to 2. So B is the correct option for this. Let's move on to question number 10. For question number 10, it says that a vector makes an angle of pi by 4 with positive directions of both x and y axis. And we know that if the name of the angles which a vector makes with x, y, and z axis is alpha, beta, and gamma. So let's say this is our space and axis x, y, and z. And there is a vector. Let's say this is the vector. Let's say r vector, and it makes an angle of, let's say alpha is the angle with the positive x-axis and beta is the angle with positive y-axis, and with z-axis it's gamma. And it's given that the angle with x and y-axis is pi by 4. So alpha is equal to pi by 4 and beta is equal to pi by 4. We have to find out gamma with the z-axis. And there is a relation. If we take the cos of these angles, so that is cos beta, cos alpha, and the cos gamma, these are the direction cosines. And there is a relation between the direction cosine, that is cos square alpha plus cos square beta plus cos square gamma is always equal to 1. And let's put in the respective values. So cos square alpha is cos square pi by 4 plus cos square beta is also pi by 4, and we have to find the value for gamma. The cos pi by 4 is 1 by root 2 the whole square, 1 by root 2 the whole square plus cos square gamma, which is equal to 1 more 1 by root 2 square is 1 by 2 plus 1 by 2 plus cos square gamma is equal to 1. So half and half is 1, and cos square gamma is 1 minus 1 is equal to 0. So cos gamma is equal to 0, and 0 we know that cos of 90 is 0. So this gets cancelled and the gamma is equal to 90. So if we check the options, this is the option C for question number 10, pi by 2. And for question number 11, for question number 11, it's given that A and B are two non-zero vectors. So A is not equal to 0 and B vector is not equal to 0. And the projection of A on B is 0. So it's given that the projection of A vector on B vector is equal to 0. Now position of A on B is given by A dot B divided by magnitude of B, that is equal to 0. And this is the magnitude, so multiplied by 0 is 0, so A dot B is 0. Now this is the dot product, and we know that the dot product is 0 when the vectors are perpendicular to each other, and then if the vectors are perpendicular to each other, that means the angle between them is pi by 2. So pi by 2, A is the correct option. Let's move on to question number 12. Okay, for question number 12, it's given that for triangle ABC, there is a triangle ABC, and it's in the let space. Let's say this is the space XYZ. Now the position vector of AB. So the position vector of AB is I cap plus j cap plus 2k cap. So this is the position vector of side AB. And now the position vector of side AC. So this is AC, whose position vector from O. This position vector is given by 3i cap minus j cap plus 4k cap. Now D is the midpoint, so D is the midpoint. We have to find the position vector of AD. So the position vector of AB, position vector of AC is given, and we have to find the position vector of AD. And we know that the position vector of AD when D is a midpoint is given by the position vector of B vector. Let's say this is a B vector and this is a B vector. So this is AB plus AC vector divided by 2, and AB vector is I cap plus j cap plus 2k cap plus AC is VI cap minus j cap. VI cap minus j cap plus 4k cap has to be divided by 2, so this gets cancelled. This is 4i cap plus 6k cap divided by 2. 2 is common, so this is 2i cap plus 3k cap divided by 2. So now this is AD vector, which is equal to 2i cap plus 3k cap. And option is option D. So this solves our question number 12. Let's move on to question number 13. Okay, for question number 13, we have to find the value of lambda for which the angle between the lines is 90 degrees. So that means these two lines are perpendicular. Okay, so let's try to understand this question first. And we are on question number 13. So there are two lines which are perpendicular to each other because angle between them is 90 degrees. So let's say this is the line 1 and this is line 2. Okay, now equation of these two lines are given. The first one is r vector is equal to I cap plus j cap plus k cap plus this is p into 2i cap plus j cap plus 2k cap. And if we compare this with the equation a1 vector plus this is, let's say, lambda, which is the vector equation of the line. So lambda into, let's say, this is b1 vector. So this is the vector to which this line is parallel. So this is the equation of this line. Now this is the second line whose equation, let's say, is the second one. R vector is equal to I plus q into I cap plus 1 plus q into lambda into j cap plus I plus q into k cap, and which is not in the standard form. So let's try to get in the standard form. If we try to open this, this is I cap plus qi cap plus this is j cap plus q into lambda j cap plus k cap plus q into k cap. Okay. So this is now r vector is equal to I, j, and k. So this is I cap plus j cap plus k cap plus q is common. So this is I cap plus lambda j cap So I cap, lambda j cap, and k cap. So this is the second equation. Now, if we compare this with the vector equation, so this is of the form a2 vector plus nu into b2 vector. So this line is parallel to, let's say, this vector b1, and this line is parallel to another vector, let's say b2. So if these two lines are parallel, so that means to the vectors to be these two lines are parallel are perpendicular. So that means b1 is perpendicular to b2, and b1 is perpendicular to b2 gives us that the dot product should be equal to 0. So b1 is, this is b1, which is 2i cap plus j cap. So this is 2i cap plus j cap plus 2j cap. Dot product of b2. b2 is I cap plus lambda into j cap plus k cap is equal to 0. Okay, now let's try to get the dot product. So this is 2 into 1 multiply the scalars and add them. So 1 into lambda plus 2 into 1 is equal to 0. So this is lambda is equal to negative 4. So the value of lambda is negative 4, and option A is the correct answer for question number 13. Let's move on to question number 14. We are on to question number 14, and for question number 14, it's given that probability of A intersection B is 1 by 8, and the probability of A naught is 3 by 4. We have to find the probability of B by A, and probability of B by A is equal to probability of A intersection B by probability of A. So we have the probability of A intersection B, but we have to get the probability of A. So this will give us the probability of A. So probability of A is equal to 1 minus probability of not A, and probability of not A is 3 by 4. So this is equal to 1 by 4. Let's put in the value, which will give us half. So the probability of B by A is half. Option A is the correct answer. Let's move on to question number 15. For question number 15, it's given that the value of the function. So this is question number 15, and our function is f of x is x square when x is greater than equal to 0, and kx when x is less than 0. So this function is defined on the number line when x is equal to 0. For the left hand derivative, it's kx and it's x squared. Okay, now it's differentiable at x is equal to 0. So since this function is differentiable at x is equal to 0, so that means the left hand derivative should be equal to right hand derivative. And how do we find the left hand derivative? In terms of limit h. So this is limit of x, sorry, this is limit h tends to 0 negative, which is the left hand derivative, and f of x plus h minus f of x upon h, and right hand derivative is denoted by x tends to 0 positive, f of x plus h, f of x upon h. Now for the left hand derivative, the function is kx. So okay, before that, our x is 0, which gives us a limit left hand derivative is f of 0 plus h minus f of 0 by h. Limit x tends to, this is h. Now, okay, now for the left hand derivative, the function is k of x. So the function is k of x, so that means f of 0 plus h. So f of 0 plus h is f of h. So I can write it as, this is f of h minus f of 0 is This is f of 0 plus h, which is f of h, and this should be kh. So this is kh and f of 0. So f of 0 for left hand derivative is k into 0, which is 0 on h. And for the right hand derivative, the value of the function is x squared. So this is f of h, and f of 0 is 0 on h. Now let's put in the value of the function for the left hand and the right hand derivatives. So f of h is, this is kx. So instead of x, we are going to put h. So this is h by h, and this is going to limit h tends to 0 positive. And for the right hand derivative, the function is x squared. So this is h squared by h, and this gets cancelled. So this gets cancelled, and here it's x, and this is equal to 0. So this is h, and we put the value of h, which is 0, so k is equal to 0. So this gives us a limit h tends to 0 positive, which is h, and if we put h, that is equal to 0, so k is equal to 0. And k is equal to 0, so the right option is option D. Let's move on to question number 16. Okay, for question number 16, we have to find the first order derivative. Question number 16 is y is equal to cos of x minus sine x on cos of x plus sine x. So okay, let's try to get this simplified first and divide both numerator and denominator by cos x. So this is cos x by cos x minus sine x by cos x, and cos x by cos x plus sine x by cos x. So this gets cancelled. It's 1. Now this is equal to 1 minus sine by cos is tan x, and this is 1 plus tan x. And this seems to be like some standard form. So instead of 1, I can write tan pi by 4 minus tan x. 1 plus, I can multiply this with 1. The value remains the same. So 1 is tan pi by 4, which is 1 into tan x. Now this is the form tan a minus tan b upon 1 plus tan a into tan b, which is equal to of a minus b. So this becomes tan of a pi by 4 minus b, which is x. Now differentiating with respect to on both sides, differentiating with respect to x, we get it's dy by dx, and differentiation of tan is secant square pi by 4 minus x, and differentiation of pi by 4 minus x is negative 1. So our first order derivative is negative secant square into pi by 4 minus x. And if we check the given options, it's the option. So option A is the correct answer. So we on to question number 17. Okay, for question number 17, we have to find the number of feasible solutions of the linear programming problem given as maximize z. So our objective function is, this is question number 17, and objective function is maximize z is equal to 15x plus 31. So let's first of all sketch the graph, and for that let's get the coordinates for 3x plus y is equal to 12, and when x is 0, y is 12, and when y is 0, x is 4. Now the next one is x plus 2y is equal to 10 and xy. So when x is 0, y is 5, and when y is 0, x is 10. So let's try to get the graph and sketch the feasible region. So these are the x and y coordinate axis. Let's say our scale on this is it's 0 to 2, 4, 6, 8, 10, and 12. This is 2, 4, 6, 8, 10, and 12. Now for the first one, it's 0 to 12. So 0 to 12, sorry, 0 comma 12 is here, and it's 12 comma 0. Sorry, 0 comma 12 and 4 comma 0. 4 comma 0. Next one is 0 comma 5. So this is 0 comma 5. And next is 10 comma 0. Okay, let's join these points. The first one is, and the second one is 0, 5, 10, 0. So this is 0, 5, and 10. Okay, we have joined it wrong. So this is 0, 12, and 4, 0. So 0, 12, and 4, 0 is here. Next in 0, 5, and 10, 0. So 0, 5, and 10, 0 is this. Okay. Now let's get the corner points. So 3x plus y is less than equal to 12. So 3x plus y is less than equal to 12, and this is the graph of 3x plus y is equal to 12. And if we check it for 0, 0, so 0 is less than 12, so it's true. So graph of this equation is towards the origin. And for second one, it's also x plus 2y is less than equal to 10. So for 0, 0, this is 0 is less than 10, which is true. So its graph is also towards the origin. And we have the common region. So this is the common region, and its corner points are 0, 5, 4, 0, and origin, and the point of intersection of these two lines. So let's get the point of intersection of 3x plus y is equal to 12. And the next one is x plus 2y is equal to 10. So x plus 2y is equal to 10. If we multiply this equation, this one with 3, so this is 3x plus 6y, multiply it with 3, and which is equal to 30. So let's subtract this equation. So our equations are 1 and 2. So if we subtract these equations, so this gets cancelled, it's 5y, and 30 minus 12 is 18. So y is equal to 18 by 5. And we can get the value of x from first. So this is 3x, and this is 18 by 5 is equal to 12. So this is 3x is equal to 12 minus 18 by 5, which is equal to 60, minus 18 by 5, 3x. And 3x is equal to, it's 42. 60 minus 18 is 42 by 5. So this is 14, and x is equal to 14 comma 5. So our the point of intersection, another corner point, is 14 comma 5 comma 14 upon 5 comma 18 by 5. So let's write down these corner points and get the value of the objective function on this. The first one is 0, 0, 0, 5, 14 by 5, and 18 by 5, and 10 comma 0. And our objective function for which we have to get the values is 15x plus 3y. So this is 15x plus, sorry, 30y. For first one, the value is 0. For the second one, 15 into 0. So this is 15 into 0 plus 330 into 5. So 30 into 5, which is equal to 0 plus 150, that is equal to 150. Next is 15 into 14 by 5 plus 18 by 5, that is 30 into 18 by 5. So this is 5 3s are 15, 5 6 are 30. This is 14 into 3. This 3 4s are 12. And okay, so 3 4s are 12, 42 plus this is 8 6 are 48, and 108, which gives us, so this is 40. Our function is 15 into 14 by 5, and 18 by 5, 14 by 5, and 18 by 5. So 15 into 14 by 5, 5 3 are is 15, 42 plus 108. So this is 150. And for 10 comma 0, it's 15 into 10 plus 30 into 0 is equal to 150. 15 into 10 is 150. Okay, so 0 5, we have this value. For 0 5, the value is 15 into 0 plus 30 into 5, which is 150. So our function is maximum at these points. Now, uh, our function is maximum at 0 comma 5, at 14 comma 5, 18 comma 5, and 150, that is 10 comma 0. So that means we have the infinite number of points on the line joining 14 comma 5 and 10 comma 0. Okay, it's not, we have taken this is not 10 comma 0, this is actually our corner point is 0 0 0 5 14 5, and this is 40. So this is 40, and our value of this is 15 into 4 plus 30 into 0, which is equal to 60. So that means this is the value on these points, the value is maximum. So this is 0 5 and 14 comma 5. So the line joining, we can say that all the points on the line joining 0 5 and 14 5. So all points on line joining 0 5 and 14 comma 5 and 18 comma 5 will have maximum value, and on the line joining these 2 points we have infinite number of points. So for this our answer should be D, that is the infinite number of points. And let's move on to question number 18. Okay, for question number 18, we have to find the feasible region of a linear programming problem that is shown in the figure. And both these inequalities, that is x plus 2y is equal to 4 and x plus y 3. This both should not satisfy the coordinate 0 comma 0. So both of them should not satisfy this coordinate, that is the coordinates of the origin 0 comma 0. So this statement should be false for, because the graph of both these are away from the origin. So the next one was x plus y is equal to 3, and if I put here 0 comma 0, so this 0 is less than 4, which means I have to make it false, so I will put in greater than equal to. Now 0 is less than 3, which will make it true, so this should be greater than or equal to 3. And so these are the two feasible, the possible constraints, and it matches with option C, x plus 2y is greater than equal to 4. If you put here 0 is greater than 4, which is false, and if you put 0 0 here, 0 is greater than 3, which is false. So these option C is the correct option for the question number 18. For question number 19 and 20, these are the assertion and the reasoning based questions carrying 1 marks each. We have to choose either of these four options. So let's move on to the 19th question. So it says that the range of sine inverse x plus 2 cos inverse x is 0 to pi. So let's check it. And it's question number 19. It's given that sine inverse x plus 2 cos inverse x. It has the range 0 to pi, so this is equal to sine inverse x, and 2 cos inverse x means cos inverse x plus cos inverse x. Now sine inverse x plus cos inverse x is pi by 2, and the range of cos inverse x is 0 to pi, and if you add pi by 2 to both these, so this is pi by 2 and pi by 2 plus pi, which gives us the range as pi by 2 to 3 pi by 2. But the given range is 0 to pi, so that means it belongs to the range 0 to pi, so that means assertion is false. So assertion is false. Let's check the reason. Now the principal value branch of sine inverse x has the range, which is true. So the reason R is true and assertion is false. Let's move on to question number 20. Okay, for question number 20, it's given that a line through the points 4, 7, 8, 2, 3, 4 is parallel to a line through the points. And there are two lines which are passing through the points. The first one is passing through 4, 7, 8, and 2, 3, 4. The second line, let's say it's passing through, this is the line L1, this is the line L2, it's passing through -1, -2, 1, and it's 1, 2, 5. Okay, if the lines are parallel, then their direction ratios should be in proportion. So this is the direction ratios should be in proportion. A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. So let's find the direction ratios, and we know how to find the direction ratios. So the direction ratios are given by x2 minus x1, y2 minus y1, and z2 minus z1. So this gives us the direction ratios. So let's find the direction ratios of this line. 2 minus 4 is -2, 3 minus 7 is -4, 4 minus 8 is -4. So these are the direction ratios of line 1. Similarly, let's get the direction ratios of line 2. So direction ratios of line 2 are 1 minus of -1 is 2, 2 minus of -2 is 4, 5 minus 1 is -4. So these are A1, B1, C1, and these are A2, B2, C2. Let's find out the ratios. So -2 by 2, -2 by 2, and B1 by B2 is -4 by 4, C1 by C2 is -4 by, this is 4 minus 8 is -4, and this is 5 minus 1 is 4. This is actually 4. Okay, so this is 4. Okay, now -4 by 4. So this is equal to -1, this is equal to -1, this is equal to -1. So that means the direction ratios are in the same proportion. So that means L1 is parallel to L2. So which says that the assertion A is true. Now, the reason the reason for this is when the lines are parallel. So this is a vector which is parallel to this line, and this is a vector which is parallel to this line. And when the two lines are parallel, say, let's say this is the equation of the line. The first one is r vector is equal to a vector plus lambda into b vector, and the second one is r vector is equal to a2 vector plus lambda into b vector. So this equation of the line is parallel to b1 vector, and this line is parallel to b2 vector. And when these two lines are parallel, then the parallel vectors are also parallel, so that means b1 should be parallel to b2. But it's given that the b1 dot product of b1 is equal to t2, and when the dot product of the parallel vectors is equal to 0, so that means these vectors are perpendicular, but which is false. So in this case, the solution is true, but the reason is false. And this solves our question number 20, and we are done with the part A. Let's move on to section. We are done with the section A. Let's move on to section B, which comprises of very short answer type questions of 2 marks each. For section B, we have very short type questions of 2 marks each, and these are 5 questions. So let's get started with the question number 21. So for question number 21, it's given that r vector is equal to 3i cap minus 2j cap plus 6k cap, and we have to find the value of r cross j caps dot product with r cross k cap minus 12. We have to find the value of this. For that, let's find out the cross product of r with j cap. So r vector is, so r into j cap, let's find its cross product. So this is 3i cap minus 2j cap plus 6k caps cross product with j cap, and this is equal to ijk 3 minus 2 6, and j we have 1 for this and 0 for I and k, which gives us I cap into, this is negative 6 minus j cap, so which is 0 plus a cap, and which is 3. So this is equal to minus 6 I cap, this is 0 plus 3k cap. So we have got the value of r with r cross k, which is equal to minus 6i cap plus 3k cap, and we have to find its dot product with r cross k. So let's find out r cross k cap, and r is 3i minus 2j plus 6k caps cross with k cap, and this is equal to I cap, j cap, k cap, 3 minus 2 6. This is 0 0 1, and we have to validate for the debt. So this is I cap minus 2 minus j cap, and this is 3 plus k cap, which is 0. So this is minus 2 I cap minus 3 j cap. So minus 2 minus 3. This is minus 2 minus 3 in j cap minus 12. Okay. So now we know how to find the dot product. So the dot product of this is sum of the product of the scalar components. So this is minus 6 into minus 2 is 12. Let me write it down for you. So minus 6 into minus 12 plus 3 into 0. We don't have the scalar component of k here. Plus we don't have the scalar component of j, which is 0 into minus 3 minus 12. So this gives me 12. This is 0, this is 0, and 12 minus 12 is 0. So our answer for this is 0. Let's move on to question number 22. For question number 22, it's given that the angle between the lines. So this is question number 22, and the first equation of the line is x minus 5 into alpha is equal to y plus 2 upon minus 5 is equal to z plus 25 by 5 upon beta. and these are the direction ratios. So the direction ratios are alpha minus 5 and beta, which will give us the first parallel vector b1. So this is alpha I cap minus 5 j cap plus beta k cap. Now the second equation of the line is x upon 1 is equal to y upon 0 is equal to z upon 1, and its direction ratios are 1, 0, and 1, which gives us the second parallel vector, which is I cap plus this is j is 0, so this is I cap plus k cap. Now the angle between the lines is pi by 4, and we know that the angle between lines is given by angle between the lines is given by cos theta is equal to dot product of the parallel vectors upon the magnitude of the product of the magnitude of the parallel vectors. So this is B2. So this is B1 magnitude of B1 into magnitude of B2, and this is whole modulus. Now we are given that the angle is pi by 4. So it's cos pi by 4. And now B1 vector is alpha I cap minus 5 j cap plus beta k cap dot product. B2. B2 is I cap plus k cap upon. Now the magnitude of B1 is root of alpha square plus 25 plus beta square into root of 1 square plus 1 square, and orders of this. So cos pi by 4 is 1 by root 2. Now the dot product of this is alpha into 1 plus minus 5 into 0 plus beta into 1. So this is now, this whole can be under root because root a into root b is equal to root ab. We write this here. Okay. Now this is alpha square plus beta square plus 25 into root 2 gets cancelled. So finally we have 1 is equal to alpha minus 5 into 0 is 0 plus beta upon this is under root alpha square plus beta square plus 25, and if we cross multiply this, this is alpha plus beta is equal to alpha square plus beta square plus 25 under root, and if we square on both sides, so square on both sides will give us, this is alpha plus beta the whole square is equal to alpha square plus beta square plus 25 and the root, and with the square roots gets cancelled. So alpha plus beta the whole square is alpha square plus beta square plus 2 alpha beta, which is alpha square plus beta square plus 25 alpha square beta square gets cancelled. So alpha beta is equal to 25 by 2. So this is the relation between alpha and beta, that is the product of these two is equal to half of 25. And this also the question number 22. Let's move on to question number 23. For question number 23, it's given for question number 23, it's given that our function is a into tan x minus cot x, where a is greater than 0, and we have to show that f of x is increasing. We have to find it's increasing or decreasing in its domain. So for that, we have to find the first order derivative. So it's a, and differentiation of tan is secant square x minus differentiation of cot is negative cosecant square x, which gives us first order derivative is equal to a into secant square x plus cosecant square x. Now a is greater than 0. Square is always greater than 0. Cosecant square is greater than 0. So that means that f dash x, this is greater than 0. So that means the function is increasing in its domain. So this function is increasing in its domain. So this solves our question number 23. Let's move on to question number 24. Before question number 24, we have two parts. The first one is to evaluate it for 3 sine inverse 1 by root 2. So let's get the first part done, and it's part A. So this is 3 sine inverse 1 by root 2 plus 2 cos inverse 3 by 2 plus cos inverse 0. Okay, now, so angle of sine for which value is 1 by root 2 is pi by 4, and angle of cos for which cos value is root 3 by 2 is cos 30, and that is pi by 6, and cos inverse 0. Cos inverse is 0 when angle is pi by 2. So this is 3 pi by 4 plus pi by 3 plus pi by 2. That is equal to 12. This is 9 pi plus 12 is 4 pi plus 6 pi. So this is 19 pi by 12 is the answer for option A. Let's move on to option D. Okay, and for option D, it's given that we have to draw the graph of f of x is equal to sine inverse x. Now our function is, this is part B of question number 24. So f of x is sine inverse x. F of x means y, so y is equal to sine inverse x, and it's the opposite of the graph for sine y is equal to x. We know the graph of sine y is equal to x. Let's try to understand this. So graph of sine y is equal to x, where x is the angle and y is the numerical value. So our numerical value is on y-axis, so maximum value is 1 and minimum is -1. So this is 0, angles are 0 to pi by 2. This is pi and 3 pi by 2 and 2 pi. On this it's negative pi by 2, pi, 3 pi by 2 and negative 2 pi. Okay, for sine 0 is 0, sine pi by 2 is sine 90 is 1, sine pi is 0, sine 3 by 2 is -1, sine 2 pi is 0. So on this side, the graph is this curve, and sine negative pi by 2 is -1, sine pi is 0, sine 3 by 2 is 1, and 2 minus 2 pi is 0. So this is the graph on this side. But this graph is inverse. The function is inverse when it's between -2 pi by 2 and pi by 2. So our graph is between minus pi by 2 and pi by 2. It's like this, but we have to draw the graph of y is equal to sine inverse x. So now the axis changes, and for y is equal to sine inverse x, the axis changes. That means now the y-axis has angles and the x-axis has the numerical values. So this is x-axis and this is y-axis. So for y-axis we have the angle 0. This is pi by 2 and 3 pi by 2 and 2 pi. For this it's negative pi by 2, negative 3 pi by 2 and negative 2 pi. And here we have the values -1, 1. Okay, now sine, for sine pi by 2, the value is 1. and sine 0 is 0. So sine minus pi by 2, the value is -1. So we have this graph for the sine, which looks like, so this is the graph. Let me just sketch it once again. And this is our graph. So now, but we have to get the graph between when x is between, so x lies between -1 by root 2 to 1 by root 2, and 1 by root 2 is equal to 1 upon 4.14, which will give us the value 0.7. So x lies between -0.7 to 0.7. So this is, let's say, -0.7 is here and 0.7 is here. So our graph is still the same for negative 0.7, -0.7. This is -1 by root 2 to 1 by root 2. And we have this is the graph. So you can give it a free hand. So this is the graph between -1 by root 2 and 1 by root 2. Now, or you can sketch it. So this graph goes like this. Okay. Now we have to find the range of the graph as well. So the minimum value is -1 by root 2. So this is sine inverse -1 by root 2 is equal to y. So sine inverse -1 by root 2, this is -1 by root 2 is equal to sine y. And we know that sine is negative when this is -1 by root 1 by root 2. This is minus sine pi by 4, which is equal to sine y. And okay, so this can be written as sine of minus pi by 4 is equal to sine y. Sine pi gets cancelled. Y is equal to minus pi by 4. So for -1 by root 2, our range is minus pi by 4. And similarly for sine inverse 1 by root 2 is equal to y. This gives 1 by root 2 is equal to sine y, which is sine pi by 4 is equal to sine y. This gets cancelled and y is equal to pi by 4. So the range for 1 by root 2 is pi by 4. So the range for this function is when x is belongs to -1 by root 2 to 1 by root 2, the range is minus pi by 4 to pi by 4. So we are done with the question number 24, and let's move on to question number 25. For question number 25, part A, we have to find the first order derivative and value of x is equal to 1. So it's question number 25, part A. And the given function is y is equal to x raised power 1 by x. So this is a function raised to the power function. And for this, we are going to take log on both sides. Okay, so log y and log of x raised power 1 by x. Now, this is log m raised power n, which is equal to n log m. So this can be written as log of y is equal to 1 by x into log x. And this is now u into v. And let's differentiate this with respect to x to get the first order derivative. So log y differentiation is 1 by y, and y's differentiation is dy by dx. And this is second function, product rule. into differentiation of first, which is minus 1 by x square, plus first function into differentiation of second, which is 1 by x. So dy by dx is equal to y, and this is uh, log x minus log x upon x square plus 1 by x square, and this is 1 minus log x. Let's replace the value of y. So y was x raised power 1 by x, and this is 1 minus log x on x square. But we have to find the dy by dx when x is equal to 1. So the first order derivative when x is equal to 1 is equal to 1 raised power 1 by 1 minus 1 minus log 1 upon 1 square. So once log 1 is 0, so this is 1 minus 0, 1 square is 1, which is equal to 1. So the value of the first order derivative at x is equal to 1 is 1 for the first part. Let's move on to the second part. And for the second part, the given functions are in the parametric form. Okay, for question number 25, part B, the first function is x is equal to a into sine of 2t. Let's differentiate this with respect to t. So a is constant and differentiation of sine is cos 2t, and differentiation of 2t is 2. So this is equal to 2a cos 2t. Let's say this is first set of equation. And the second function is y is equal to a cos of 2t plus log and t. Okay, and let's differentiate this once again with respect to t. So its constant and differentiation of cos is negative. So this is negative sine 2t into 2 plus differentiation of log is 1 by x. So this is 1 by tan t, and differentiation of tan t is secant square t. This has to be simplified, so it's dy by dt is equal to a. Now this can be written as minus 2 sine 2t and sine by t upon cos by t for tan. Secant square is 1 by cos square t, so this gets cancelled. And we have dy by dt is equal to a. This is minus sine 2t plus this is 1 upon sine t into cos t, and let's multiply and divide this with 2. So 2 sine t into cos t is sine 2t. So this is now dy by dt is equal to a. We can take 2 common. So let's take 2 common. So if 2 is common, a is already out. This is minus sine 2t plus 1, and 2 sine t into cos t is sine of 2t. And if we take LCM here, so this is sine of 2t, which is negative sine square 2t plus 1. This is equal to 1 minus sine square 2t upon sine of 2t. Now 1 minus sine square x is cos square x. So this is cos square 2t by sine 2t. And now this can be written as, so cos square 2t, for 1 cos upon sine is cos 2t, and 1 upon sine 2t is cosecant. Okay, sorry. So this is equal to 2a into cos square 2t can be written as cos 2t into cos 2t upon sine 2t. Now sine my cos is cot and we are left with cot 2t. So this is dy by dt. But we have to find first order derivative with respect to x, which is dy by dt divided by dy by dx. And dy by dt is 2a into cot of 2t into cos of 2t upon dy by dx. So dy by dx was a cos 2t. So this is 2a cos 2t. Now 2a, 2a and cos 2t, 2t gets cancelled. So finally, the first order derivative is equal to cot of 2t. And this solves our question number 25. Let's move on to section C. For question number 26, we are on section C, and this section comprises of short answer type questions of 3 marks each. The first one is we have to find the general solution of the differential equation, and the given differential equation is this is differentiation of x into y square is equal to 2y into 1 plus x square. So this is yet to be differentiated. So let's differentiate this using the product rule. And the product rule says that it's the first function. This is, sorry, the second function into differentiation of first, which is 1, plus first function into differentiation of y square, which is 2y into dy by dx. And this it has to be written as it is. So we are not differentiating the whole equation, but just this side because it's differentiation of xy square. Okay, now our differential equation, it looks like y square plus 2xy into dy by dx is equal to 2y into 1 plus x square. Let's try to get it into some known form. And for that, let's remove this 2xy. And to remove this, we have to divide each and every term by 2xy. So y square plus 2 or 2xy and 2xy into dy by dx divided by 2xy is equal to 2y into 1 plus x square upon 2xy. So 2, 2 and y gets cancelled. This gets cancelled. Now this is y upon 2x plus dy by dx, which is equal to 1. Okay, so this is y upon 2x plus dy by dx, and this is 1 plus x square upon x, which is equal to 1 upon x plus x square upon x, and this is now 1 upon x plus x. So I can rearrange it like dy upon dx plus y upon 2x is equal to 1 upon x plus x. Now this is of the form dy by dx plus py is equal to q. And if we compare 1 and 2, it gives us p is equal to, this is 1 upon 2x and q is equal to 1 upon x plus x. And we know that for this type of equation, differential equation, we have the general solution given by the formula. But before that, we have to find the integrating factor, which is integration of p into dx. And this is integration of p is 1 by 2 into dx. So 1 by 2 is out, and we have to integrate 1 by x into dx, and integration of 1 by x is log x, which can be written as log x raised power half, and this is equal to x raised power half. So our integrating factor is equal to x raised power half. Now, for this form, the general equation, The general solution of the equation is given by general solution of this differential equation is given by the formula. Let's write down the formula. So this is y into integrating factor is equal to integration of q into integrating factor into dx. So integrating factor is x raised power. This is x raised power half, and q is 1 upon x plus x. So this is 1 upon x plus x, and integrated factor is x raised power half into df. And let's try to simplify this. So this is x raised power half upon half, sorry, x raised power half upon x plus x into x raised power half is x raised power 1 plus half is 3 by 2 into dx, and this has power 1. So this can be written as this is x raised power half minus 1 is negative half plus x raised power 3 by 2 into dx. Now, this is y into x raised power half, which is equal to, so x raised power half differentiation is x raised power minus half plus 1 upon minus half plus 1, and next is x raised power 3 by 2. So this is 3 by 2 plus 1, x raised power 3 by 2 plus 1 upon 3 by 2 plus 1. And let's add the integral constant. So this is y into x raised power half, which is equal to, okay, so this is equal to x raised power minus half plus 1 is half. This is half. 3 by 2 plus 1 is x raised power 5 by 2, 5, 2 plus c. And this can further be simplified. This is y into x raised power half, and 2, that is 2 into x raised power half plus 2 by 5 is x raised power 2 plus c. Now let's remove this x raised power half. This is 2 into x raised power half divided by x raised power half, 2 by 5 x raised power 5 by 2 upon x raised power half plus c upon x raised power half. So this gets cancelled. This is now y is equal to 2 plus 2 by 5. 5 by 2 minus half. So 5 by 2 minus half is 4 by 2, which is 2. So this is x squared, and this can be written as c upon root x. So this is our general solution for part A, which is y is equal to 2 plus 2 plus 2x squared upon 5 plus c upon root x. Let's move on to the next part. It is part B. Okay, for part B, we have once again solved the differential equation. So we have one more differential equation. So first of all, let me clear this out. Okay, for part B, we have to solve the differential equation, and the given differential equation, it's part B of question number 26, which is x into e raised power y by x minus y plus x into dy by dx is equal to 0. And let's try to get it converted into substandard form. For that, let's remove this x. So if I divide each and every term with x, so x into e raised power y by x minus y plus x into dy by dx is equal to 0. Divide each and every term by x. So this gets cancelled, this gets cancelled, and now we are left with e raised power y by x minus y by x plus dy by dx equal to 0, and this can be written as dy by dx is equal to y by x minus e raised power y by x. And let's make the substitution here. So y by x is equal to v, which gives us v is equal to, so y is equal to, so this gives us y is equal to v into x, and differentiating with respect to x, we get a differentiation of y is dy by dx, and vx, it's v into differentiation of x is 1, and x into dv by dx. This is equation 2, this is equation 1. If we compare 1 and 2, so v plus x into dv by dx is equal to, from 1 and 2, this is y upon x minus e y raised power x, and let's substitute the value x, x into dv by dx. This is v minus e raised power v and v gets cancelled, and separating the variables gives us, let's cross multiply, which gives us dv upon e raised power v is equal to minus dx upon x. And integrating on both sides will give us, this is integration of e raised power minus v into dv, and this is minus log x plus c. Integration of e raised power minus v is e raised power minus v, and minus v's differentiation is -1. So this is equal to minus log x plus c. Now this can be written as, let's replace the value. So this is negative e raised power minus v is equal to minus log x plus c, and let's replace the uh, which was minus y by x, and this is minus log x plus c. And this can further be simplified, so let's try to simplify it. And okay, let's remove this negative sign. So this is e raised power, and this is log x plus minus c. So minus c is again a constant. So our solution for this is e raised power minus y by x is equal to log of x. This is again constant, so let it remain c, because minus c is again constant, so this is c. So e raised power, or you can just make it c1. Okay, minus c1 is again constant, so substituted with c. So this is our solution for the given differential equation. And this solves our question number 26. Let's move on to evaluate the question number 27. Before we are on question number 27, so for question number 27, let's say our integral is I. This is definite integral with limits 1 to 3, and square root of 4 minus x upon the root of x plus under root 4 minus x into dx. Let's say this is our first set of equation, and for this we are going to use the property which is, so 1 plus 3 is 4, so we are going to use the property here that is a to b f of x into dx. This can be written as integration of a to b f of a plus b minus x into dx. Okay, if we use this property on this, it gives, so instead of x, we have to write a plus b into x. So a plus b is 1 plus 3 minus x, which is 4 minus x. So we are going to replace x with 4 minus x. So its integration of 4 minus x is 4 minus x upon 4 minus x plus 4 minus 4 minus x into dx. So this is now, let's open up the bracket, which is 4 minus 4 plus x upon under root of 4 minus x plus 4 minus 4 plus x. So this gets cancelled, this gets cancelled. And now I is equal to integration of 1 to 3. This is root x upon root of 4 minus x plus under root x. Okay, let's say this is our first set of equation and we are going to add 1 and 2. So 1 plus 2 gives I plus I is 2I. Its integration 1 to 3. And if we add this, this is now the root of 4 minus x plus root of x upon root of 4 minus x plus root of x. Okay, this gets cancelled and this is 1 into dx. Integration of 1 is x. This is 1 to 3. So 3 minus 1 is equal to 2. And 2I is equal to 2, which gives us I is equal to 1. And this is also question number 27. Let's move on to question number 28. We're admitted. Before question number 28, we have to evaluate the definite integral from with the limits of 1 to e. And question number 28, let's say our integral is I is equal to 1 to e. And this is 1 upon 4x square minus x log x the whole square into dx. Okay, now uh, let's try to simplify it first. So this is 1 upon 4x square, and if we take this is all is under root, and if we take x square, let's open this x log x the whole square. So this is x log x. So this is x square log x the whole square into dx. Now we can take x square common. So if x square is common, so this is 1 upon x square is common, which is 4 minus log x the whole square into dx for the limits 1 to e. So this is I. And this is under root. So square root of x square is 1 by x under root 4 minus log x the whole square. It's dx with the limits 1 to e. And now it's ready for the substitution. We can make the substitution because the differentiation of log x is 1 by x. So let log x is equal to t. So this is 1 by x into dx is equal to dt. Let's get the new limits as well. So when x is equal to 1, so when x is equal to 1, t is equal to 0. And when x is equal to e, t is equal to log e, which is 1. So our integral is ready with the new limits. This is 0 to 1. And 1 by x into dx is dt. So it's dt and it's under root 2 square minus log x is t square. And now this is of the form this integration. This is, we know that integration of under root of a square minus x square into dx is equal to 1 by a sine inverse x by a, or this is sine inverse x by a plus c. So let's use this formula, and I is now equal to, this is sine inverse x. Instead of x we have d by a, which is 2, and this has to be value for the limit 0 to 1. So this is sine inverse half minus sine inverse 0. And sine inverse half is, we know that sine pi by 6 is equal to half. So this is sine inverse half is pi by 6. And sine inverse 0 is 0. So integral for this well is I is equal to 5 by 6, and this solves our question number 28. And let's move on to question number 29. Okay, we are going to solve question number 29 part A. So question number 29 part A, then we have to integrate. Let's say our integral is I is equal to integration of cos x by sine 3x. Okay, and for this, let's try to simplify this, and we know that sine 3x formula. So sine 3x is equal to 3 sine x minus 4 sine cube x. So let's replace this here, and our integral is I is equal to cos of x upon 3 sine x minus 4 sine cube x into dx. Okay, now it's ready for the substitution because we know the differentiation of sine is cos. So let's substitute sine x. So sine x is equal to d, and differentiation of sine x is cos x. Differentiation of x is dx by dt. I am going to write dx here and shift dt to that side. Differentiation of t is 1. So let's make the substitution and get our integral in terms of t. So cos x into dx is dt. 3 sine x is 3t minus 4 sine cube. Okay, this is not 4 sine cube t. This is sine is t, so this is 4t cube. And it has to be further simplified. For this, let's take t cube common. So if I take t cube common here, so taking t cube common means we have to divide each and every term by t cube. So this is 3 by t square minus 4 and dt. Okay, now we can make another substitution because the differentiation of t square is gives us t cube. So let's say 3 upon t square minus 4 is equal to z. 3 is constant, and differentiation of 1 by t square is minus 2 upon t cube. Differentiation of 4 is 0. So this is, we are differentiating this with respect to z. So this is dt and this is dz. Okay, this is dz by dt. This is dz and dz by dt. Okay, difficult differentiation of z is 1. So finally we have minus 6 upon t cube into dz is equal to dt, which gives us dz upon t cube is equal to minus dt by 6. Let's make the substitution. So this dt upon t cube is minus 6. Minus 6 minus, look at this, is we have made we have differentiated this with respect to z. So this is dz by dt, and dz by d cube is equal to minus dt by 6. So this is actually, we have differentiated this. So this is dt by dz, and dt is equal to z dz. So this is dt upon t cube is equal to minus 1 by 6 dz. So dt upon d cube is equal to minus 1 by 6. So dt by t cube is minus dz by 6, and let's make the substitution. So I is equal to minus 1 by 6 is out. This dz, and t cube is also included, and this 3t square minus 4 is z, which is equal to minus 1 by 6 log z plus c. And let's replace the value of z, which was 3 upon t square minus 4 plus c, and let's replace the value of t. T was sine x, so this is sine square x minus 4 plus c, and sine square x is 1 upon sine square x is cosecant square, so this is 3 cosecant square x minus 4 plus c. So I is equal to minus 1 by 6 log 3 cosecant square x minus 4 plus c is the answer for the part A. Let's move on to part B, for which we have to find the integral once again. And for that, let me remove this. Okay. Now, for question number 29, part B, our integral is, let's say, I is equal to x squared. So this is the product of two functions, log of x squared plus 1 into dx. This is u and this is v, and we are going to use integration by parts. And for using integration by parts, let's put them in order using ILATE. So algebra log is the first function, so this is the first function, and algebra x square is the second function. So I is equal to, this is log of x square plus 1 into x square into dx. And now we are going to use using integration by parts. We get I is equal to. So integration by parts says that it's the first function into integration of second function minus integration of differentiation of first function into integration of second function. The whole has to be differentiated. Okay, this is now I is equal to log of x squared plus 1, and integration of x squared is x cubed by 3. Differentiation of x squared is 2x into its x cubed by 3. Okay, this has to be differentiation of log. The first function is differentiation of log of x squared plus 1. And integration of x squared into dx. Okay, so differentiation of log of x squared plus 1 is 1 upon x squared plus 1, and differentiation of x squared is 2x into integration of x squared is x cubed by 3 into dx. Okay, so I is equal to, now this is x cubed by 3 into log of x squared plus 1. 2 and 3 are constant, so this is out, minus 2 by 3, and we are left with integration of x raised power 4 upon x squared plus 1 into dx. Okay, now this is an improper function where the degree of the numerator, that is x raised power 4, it has degree 4, this has degree 2, so we are going to divide and convert this into the proper form. So let's divide x raised power 4 with x squared plus 1, so this is x squared, and x raised power 4 minus x squared, and this gets cancelled, so this is x squared. So okay, so this is positive and it has to be negative. This is negative, so the negative x squared, so it's minus 1, and it's minus x squared minus 1. So let's subtract them, which gives us 1. So this integration, I can write it as I is equal to x cubed upon 3 into log of x squared plus 1 minus 2 by 3. And instead of x raised power 4 by x squared plus 1, I can write x squared minus 1 plus 1 upon x squared plus 1 into dx. Okay, now we have three different terms, and now it's easy to integrate. So I is equal to x cubed by 3 into log of x squared plus 1 minus 2 by 3. Integration of x square is x cubed by 3. Integration of minus 1 is minus x. And this is integration of 1 upon x squared plus 1 is tan inverse x plus c. So this is our answer, and if you want you can also expand it. So this is x cubed upon 3 into log of x squared plus 1. So this is minus 2 x cubed by 9 plus 2x by 3 minus 2 by 3. This is minus 2 by 3 tan inverse x plus c. Okay, and this solves our question number minus 2 by 9x cubed plus 2x by 3 minus 2 by 3 tan inverse x plus c. And this solves our question number 29. Let's move on to question number 30. For question number 30, we have to determine graphically the minimum value of the following objective function. And it's given that the objective function is z is equal to 500x plus 400y, and the constraints are x plus y is less than equal to 200, x is greater than equal to 20, y is greater than equal to 4x, and y is greater than equal to 0. Okay, so we have to find the minimum values. Objective function is minimum z, and let's quickly draw the graph for the constraints. These are the constraints, and we are going to draw the graph for x plus y is equal to 200, x is equal to 20, and y is equal to 4x. Okay, now let's get our coordinate axis. Okay, and so these are our coordinate axis, and we are going to use a scale of 20. So this is 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200, let's say. And similarly here we are going to stick to the first quadrant: 0, 20, 40, 60, 80, 100, 120, 140, and so on. Okay, for this one, when x is 0, y is 200, and when y is 0, x is 200. So therefore we need to get the value. Okay, now this is 140, 160, 180, and 200. And this is the point 0, 200, and 200 comma 0 is here. So this is 200 comma 0, and we are going to join these 2 points. So let's join these 2 points. Okay, so we have got our first equation graph, that is x plus y is equal to 200. And the next one is x is equal to 20. So x is equal to 20 is a line parallel to y-axis. This is x is equal to 20. Third one is y is equal to 4x. So y is equal to 4x. And let's try to get two coordinates for y is equal to 4x. So when x is equal to 20, so when x is 20, y is 80. And when x is, let's say 10, y is 40. So I have 2 points, 20, 80. So when x is 20, y is 80. So 20 and 80. Okay, this is the point 20, 80. And the next is when x is 10, y is 40. So when x is 10, or rather, let me take some value greater than 10. So let's take x is equal to 30. So when x is 30, y is what, 20. So when x is 30, y is 120. So when x is 30, y is 120, or we can also take it as 40. So this will give me 160. So it's 40 and 160 is here. It's 40 and 160. So this line goes through. Okay, so this is the equation for y is equal to 4x, x plus y is equal to 200, and this is x is equal to 20. Let's try to get the feasible region now. So the first one, the first equation is x plus y is less than equal to 200. So for x plus y is less than equal to 200, if we check this equation for the coordinate 0, 0, so 0 is less than 200, which is true. So this has the graph towards the origin. And now for x is greater than equal to 20. So for x is greater than equal to 20, if we check it for 0, comma 0, so 0 is greater than 20, which is false. So this has the solution region in this plane. Now we are left with y. So y is greater than equal to 4x. So y is greater than equal to 4x. And if we check it for 0, 0, so this is 0 is, or let's try to check it for some other point. So y, let's say it's 20, comma, this is y is equal to 4x. So let's check it for 10 and 40. So if we check this equation for 10 and 40, y is 40 is greater than 4 into 10 is 40. So this is equal. Let's get some other point. Let's say 10 and 50. So 10 and 50. So this is for this 10 and 50. Okay. So I'm going to check this equation for y 10, 50. So y is 50. So this is 50 is greater than equal to 4 into 10 is 40, which is false. So 10 and 50 lies in this region. So this equation, this one has the graph. So it's y is greater than equal to 50 is greater than which is true. Sorry. So 50 is greater than 40, which is true. So this is true. And so that means this has the graph in this plane. And if we try to find the common region, so our common region is this one. This is the common region. And now let's try to get our corner points. We have, let's say, the corner point A and B and C. So our corner points are, first one is A. So A is 20 comma 80. So this is 20 and 80. Let's try to get the second corner point. So second corner point B is the point of intersection of x is equal to 20 and x plus y is equal to 200. So x plus y is equal to 200, and if we solve them, so 20 plus y is equal to 200, y is equal to 180. So this corner point is 20 comma 180. So this is 20 comma 180. So b is 20 comma 180. And the third corner point C, this is C, and which is equal to, this is 40. So let's try to solve this. This is x plus y is equal to 200. Third corner point C is the point of intersection of x plus y is equal to 200 and y is equal to 4x. Y is equal to 4x. In solving this gives x plus 4x is equal to 200. So this is 5x is equal to 200 and x is equal to 40, which gives y is equal to 160. So this is 40 comma 160. And let's try to get the minimum z. Minimum z was 500x plus 400y. So this is 500x plus 400y. Okay, so this is 500 into 20 plus 400 into y, which is 80, which gives 5 twos are 10 and 1000 plus 8 fours are is 32 and 32,000. So which gives us 32 plus 10 is 42,000. Next is 500 into 20 plus 400 into 180. So 500 into 20 is 10,000 plus. So it's 400 into 18 is 18, 4s are is 8 4s are 32, 72,000, which gives us 72 plus 10 is 82,000. The next is 40 into 160. This is 160. So this is 500 into 40 plus 400 into 160. 5 fours are 20 and 3 zeros plus 16 into 4 is 64 and 3 zeros. So 64 plus 20 is 84,000. Okay, now the minimum value is, this is the minimum value 42,000. So that's what was asked in the question, and we have to find the minimum value. So minimum value is 42,000, which is at 2080 corner point. And this solves our question number 31. Let's move on to question number 30. Let's move on to question number 31. For question number 31, it's given that a pair of dice, part A, so we are on question number 31, part A, and it's given that a pair of dice is thrown simultaneously, and if x denotes the absolute difference of numbers obtained on the pair of dice, then we have to find the probability distribution of x. Okay, this is a pair of dice, and let's say, so the total number of outcomes we know is 23 for a pair of dice, and total outcomes for a pair of dice is 36. And let's say this is our first die with the numbers 1, 2, 3, 4, 5, and 6. And the next one, the other die has the numbers 1, 2, 3, 4, 5, and 6. So our possible outcomes will be 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. This is 1, 2, 1, 3, 1, 4, and 1, 5. And this is 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. This is 1, 6. Similarly, it's 3, 2, 4, 2, 5, 2, and 6, 2. And this is 3, 3, 4, 3, 5, 3, and 6, 3. This is 4, 4, 4, 5, 4, 6. Okay, sorry, this is actually 3, 4. So this is 3, 4, 3, 5, and 3, 6. This is 4, 4, 4, 5, and 4, 6, 5, 4, 5, 5, 5, 6, 6, 4, 6, 5, and 6, 6. Okay, so these are the possible outcomes, and it says that if x denotes the absolute difference of numbers, absolute difference of numbers means we have to take the absolute values. Let's say these are the numbers. So absolute difference is 1 minus 2 is negative 1, which is 1. So this is the absolute difference. That is, if it's negative, we have to consider only the positive value. Now, the minimum difference on the pair of dice can be 0, and the maximum difference can be the difference between the maximum number and the minimum number, which is 1, which is 5. So x denotes that x be a random variable that denotes the absolute difference. Okay. So x is a random variable that denotes the absolute difference between two numbers on a pair of dice, and now x can take the value either it's 0, either it's 1, either it's 2, 3, 4, and 5. So let's find out the probabilities, respective probabilities. Now, absolute difference is 0 when we have the same numbers on the dice, and the same numbers are, these are the same numbers, which are 6. So this is absolute difference is 6 by 36. And when the absolute difference is 1, so absolute difference is 1 in these cases: 2, 1, 3, 2, 4, 3, 5, 4, 6, 5, and these 1. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. And if we count these numbers, these will be in number 10. So these are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the absolute difference when it's 1, it's on 10 favorable outcomes. So this 10 by 36. Now 2. 2 is the difference on these numbers: 3, 1. So 3, 1, 4, 2, 5, 3, 6, 4. And also it's 1 3. If we change the order, so it's 2 4, 3 5, and 6 4. And these numbers are 1 2 3 4 5 6 7 and 8. So this is 8 by 36. Now the absolute difference for 3 is on these numbers 5, 4 minus 1, 5 minus 2. So this one, 5 2, and 6 3. And their receipt and their the numbers change when we change their order. So this is 1 4, 2 5, and 3 6, which is 6. So this is 6 by 36. And similarly, it goes on decreasing. This will be 4 by 36, and for 5, it will be 2 by 36. So this is the probability distribution for the sum of absolute value of the difference of two numbers on a pair of dice. Okay, let's move on to the second part. Okay, that is the or, the B part. And for this, let's try to get some space. Okay, for part B, it's given that there are two coins. One of them is biased coin, such that the probability of the first coin is biased, and the probability of head, the ratio of probability of head to probability of tail is 1 by 3 on the biased coin. And the other is a fair coin. So one is biased and the other is a fair coin. A coin is selected at random and tossed once, and if the coin showed head, then find the probability that it is a based coin. So this question is based on Bayes theorem, and let's say this is part B. So let's say E1 be even of selecting biased and E2 be event of selecting unbiased coin. Okay, now the probability of even, because there are two coins, so selecting either of them will give us the probability half. We can select either of them out of the two coins. Now it's given that the probability for unbiased, for this is the biased coin. There is one more information for the biased coin. It's given that probability of head, the ratio of probability of head to probability of tail is 1 is to 3. And for biased coin, the probability of head, this is for unbiased coin. We all know that the probability of head or probability of tail is 1 by 2. No, we have to get head. So head is the common event. So let A be event of getting a head on the selected coin. Okay. Now probability of getting a head if the first coin is selected. So the first coin is a bias coin, and we have total 4 cases here. And out of these 4 cases, we are getting head on the one case. So probability of head by selecting the first coin. If the first coin is selected and to get head, it will be 1 by 4, total 4 cases, and we are getting 1. Out of the 4 cases, we are getting head on the one. Similarly, probability of getting head when the second coin is selected, it's half because it's a unbiased coin. Now, what is being asked in the question is that the head shows up, that is, head is already there, and we have to find that it was from the biased coin, that is from the even. So this is the probability that we have to find, and we are going to use Bayes theorem. So by using Bayes theorem, we get this is now probability of E1 into probability of A by E1. Same here, probability of E1 into probability of A by E1 plus probability of E2 into probability of A by 2. Let's put in the respective values. E1 is half, probability of A by E1 is 1 by 4. It's again half into 1 by 4. This is half into half. So this is 1 by 8 upon 1 by 8 plus 1 by 4, which gives us 1 by 8. LCM of 8 and 4 is 8. So this is 1 plus 2, which gives us 1 by 8 upon 3 by 8, which gets cancelled, and this is 1 by 3. So probability of getting hit from the unbiased point is 1 by 3. Okay, so this solves our question number 31, and let's move on to section D, which has long answer type questions of 5 marks each. Okay, we are on section D, and section D, this section comprises of long answer type questions of 5 marks each. Section D and 32nd question, it's 32. So the function is defined from real to real numbers. So this is a function that is defined from real to real numbers. That is, the domain and codomain are real numbers. And the function is f of x is equal to fx minus 3 by 4. We have to show that it's both 1, 1 and on 2. So let's get started and show that it's 1, 1. For this, let's consider these two values. So x1 and x2, let's say these two belongs to the real numbers. And if, let's say, f of x1 is equal to f of x2, and we are able to show that, so x1 and x2 are two different values and both these have same images, and if we are able to show that these two are equal, that means a unique image has a unique pre-image. That is, for every output there is a different input. For every input there is a different output. So f of x1 according to this function is, this is 5x1 minus 3 by 4 is equal to 5x2 minus 3 by 4. 4 and 4 gets cancelled. So 5x minus 3 is equal to 5x2 minus 3. And this is 5x1 is equal to 5x2. 5 and 5 gets cancelled. x1 is equal to x2. Therefore, f is 1, 1. And now for onto, our given function is, it's given that f of x. So f of x is 5x minus 3 by 4, and f of x is ry. So let's try to get the value of x, so which is 5x minus 3 is equal to 4y, and which gives 5x is equal to 4y plus 3. So x is equal to 4y plus 3 by 5. Okay, we have got the value of x, so let's find out the value of 4y plus 3 upon, for, let's see if for every x there is a y or not. So this is 5 into 4y plus 3 upon 5 minus 4. Sorry, it's 5 minus 3. So this is minus 3 upon 4. And this is 20y plus 15 minus 15 upon 20. So this gets cancelled, and this is 20y upon 20. So that means for every x, that is 4y plus 3, for every x there is a y. So this means range is equal to codomain, and therefore the function is odd function. So therefore the function is both 1, 1 and onto. So function is both 1, 1 and onto function. Okay, so we are done with the 32nd question and let's move on to 33rd. For question number 33, it's given that area of the region bounded by the line y is equal to mx and the curve x square plus y square is equal to 4 to x-axis. In the first quadrant is pi by 2 units and using integration we have to find the value of m. So let's first of all try to sketch the graph of the region bounded by the line y is equal to mx, and let's say this is our y-axis and this is the x-axis. So we have to stick to the first quadrant. Okay. Now it's given that the equation of the line is y is equal to mx. Now this equation y is equal to mx, it passes through the origin, because if x is equal to 0, this will give us y is equal to 0. So this line has the graph which passes through the origin. So let's say this is the equation of the line y is equal to mx which passes through the origin, and this is y is equal to mx. And the next is the equation of the curve x square plus y square is equal to 4. And then the x square plus y square is equal to 4 is the equation of the circle with center at its origin. We know that the standard equation of the circle is x minus h the whole square minus plus y minus k the whole square is equal to r square. And if we compare these two equations, h and k both are 0 and radius is equal to 2. So let's draw a circle with radius 2. So let's say this is the circle with radius 2 units. Now we have to find the point of intersection, because the region whose area is given is between line y is equal to x and curve x curve, that is x square plus a y square is equal to 4. So this is the region whose area is given. Okay, this is the region and its area is given. So let's find out the point of intersection of this is 0 and the radius is, this is 2 units. So coordinate of this is 2 comma 0. The x-axis and the point where the circle intersects is 2 comma 0. Let's say this is point A and this is point B. Okay, now let's find the point of intersection of the circle and the line. So line's equation is y is equal to mx and circle's equation is x square plus y square is equal to 4. If we put the value of y here, so this is m square into x square is equal to 4, which gives x square into 1 plus m square is equal to 4. So x square is equal to 4 upon m square, which gives the value of x, which is plus minus 2 upon root of 1 plus x square. But because we are in the first quadrant, so the x is positive, so x is 2 under root 1 plus m square and y is mx. So the coordinates of the point of intersection are 2 upon under root 1 plus x square in, and the coordinate is mx. So that means we can divide this region into two parts, and this point of intersection, because the coordinates of this point are 2 under root 1 plus m square, so that means this distance is, so this distance is 2 upon under root of 1 plus m square. Okay, so now the area of this region is the area of the region, let's say this is point C. So area of region OAC plus area of region ABC. So area of the region, the complete region is OABO. OABO is equal to, or let me write it this way. So let's say the area of the region OACO. So OACO. So OACO plus area of region ABCA. This one. Area ABCA. So this is given it's pi by 2 square units, and we have to find the value of m. Now area of region OACO, this lies under this curve which is y is equal to mx. So this is, we can find the area of this region OACO using the integration 0 to 2 upon under root of 1 plus m square into y into dx plus this is the next region is formed here to this coordinate, this length is 2. So the area of the region ABCO will have the limits 2 upon under root 1 plus m square to 2, and its y into dx is equal to pi by 2. Now we have to put the respective values of the y. So this region is under the curve y is equal to mx. So y here is it's under root of 0. 2 upon under root of 1 plus m square. Y is mx into dx plus this is 2 under root 1 plus m square to 2, and this region is under the curve, that is the equation of the circle. From here we can get y is equal to 4 minus x square. So we can write the value of y, which is under root 4 minus x square into dx is equal to pi by 2. Now m is constant, so it's out, and we are left with x. So integration of x is x square by 2, and it has a limits 2 upon under root 1 plus m square 0 plus. Now this is of the form a square minus x square. So under root a square minus x square, which is integration of under root a square minus x square is x by 2. So this is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a plus c. We are going to use this for the formula here, so which gives it's x by 2, so it's x by 2 under root of 4 minus x square plus, okay, this is x square, and next is a square by 2. So a square is 4, so 4 by 2 is 2, and it's sine inverse x by a, which is 2. So this is actually, we can write instead of 4, we can write here it's 2 square, and we have used the formula, and this has to be evaluated for the limits. The limits are 2 under root 1 plus m square to the upper limit 2 and pi by. Okay, so let's simplify this, and now this is m into n x square. So 2 is out, and x square is 4 upon 1 plus m square. So this is 2 plus, if we put 0, this is 0, and this has to be evaluated for, let's put in the upper limit first. So 2 by 2 is 1, and this is 4 minus 2 square is 0, so this is 0 plus this is 2 sine inverse 2 by 2 is 1 minus. So we have put the value, the upper limit in this, and now we will evaluate it for the lower limit. This is 2 upon, okay, this is 2 upon under root of 1 plus m square. Now If I put here, this is x 2 upon under root of 1 plus m square by 2. 2 and 2 gets cancelled. Under root 4 minus x square. So this is 4 upon 1 plus m square plus 2. This is sine inverse x. X is 2 under root 1 plus m square by 2 is equal to pi by 2. Okay, now this one is 2m upon 1 plus m square, and this is 2 sine inverse 1. Sine inverse 1 is pi by 2 minus. Let's open up the bracket. So this one is now 1 upon under root 1 plus m square. I'm not going to open the bracket. So this is, if we take LCM here, so this is under root 1 plus m square, and this is 4 plus 4m square minus 4 plus 2. Now 2 and 2 gets cancelled, so this is 2 sine inverse 1 upon under root 1 plus m square is equal to pi by 2. Okay, so 4 and 4 gets cancelled. I'm going to open the bracket now. 2 and 2 gets cancelled, so finally we have 2m upon 1 plus m square plus I minus. So under root 4m square is 2m, and under root 1 plus m square into under root 1 plus m square is 1 plus m square minus 2. This is now, we have opened up the bracket, so this is minus now, minus 2 sine inverse 1 upon root of 1 plus m square, which is equal to pi by 2. Now this terms gets cancelled, and finally we have minus 2 sine inverse 1 upon under root of 1 plus m square, which is equal to pi by 2. Let's shift pi to this side. So this is pi, and this is now minus pi by 2. So minus and minus gets cancelled. So this is now sine inverse 1 upon root of 1 plus m square is equal to pi by 4. Now we know that sine inverse 1 is pi by 4. So instead of pi by 4, so instead of this pi by 4, I can write sine inverse 1, because sine inverse 1 is pi by 4. Now sine inverse gets cancelled. So this is 1 upon under root of 1 plus m square is equal to 1. And if I square on both sides, this gives me 1 plus m square is equal to, this is under root 1 plus m square is equal to 1. And if we square on both sides, this is 1 plus m square is equal to 1. And m square is equal to, okay, let me check the values once again. Okay, so this is sine inverse 1. Okay, pi by 4. This is, okay, we know that it's sine inverse 1 by root 2. That is pi. So sine inverse 1 by root 2 is pi by 4. It's not sine inverse 1, sorry. So this is now 1 upon under root of 1 plus m square, that is 1 by under root 2. And if I square on both sides, this gives me 1 plus m square is equal to 2. So m square is equal to 2 minus 1, which is equal to 1. And m is equal to plus minus 1. But it's given in the question that m is greater than 0. So find the value of m. M is greater than 0. So we will ignore or reject the negative value. So it's, we will write that m is equal to 1 because it's given that m is greater than 0. So this is the value of m, which is 1 for question number 33. And let's move on to question number 34. Okay, we are on question number 34. And for this, we have to show that if matrix A is given, and we have to show that a cube minus 6a square plus 7a plus 2i is equal to null matrix. For this, we need a square and a cube. So let's calculate that. And it's question number 34, part A. So our A matrix is A is equal to 1, 0, 2, 0, 2, 1, 2, 0, 3. And let's calculate A square. So A square is A into A, which is 1, 0, 2, 0, 2, 1, 2, 0, 3. Okay, let's multiply this. Okay, and now this is equal to, so first row, first column, 1 into 1 is 1, plus 0 into 0 is 0, 2 into 1 is 4, along with the second column. So 1 into 0 is 0, 0 into 2 is 0, plus 2 into 0 is 0. So 1 into 2 is 2, 0 into 1 is 0, 2 into 3 is 6. So next is 0 into 1 is 0, and 2 into 0 is 0, and 1 into 2 is 2. 0 into 0 is 0, 2 into 2 is 4, and 1 into 0 is 0. So 0 into 2 is 0, and the 2 into 1 is 2, plus 1 into 3 is 3. So with the third row, it's 2 plus 0 plus 6, 0 plus 0 plus 0, and 4 plus 0 plus 9. Okay, and now this is equal to 5, 0, 8, 2, 4, 5, 8, 0, and 13. So this is a square. And now we have to find a cube. So we will multiply a square with a. And so let's find out a cube. So which is a square into a. So we have the value of a, which is 508, 2, 4, 5, 8, 0, 13. This is the value of a square has to be multiplied with a, and a is, the value of a is 102, 102, 021, and 203. Okay, and if you multiply this, the first row, first column, and it's 5 plus 0 plus 16. This is 0 plus 0 plus 0, and 8 results. Okay, so the first one, first row, first column is 5, 0, and 16. Second column, 0, 0, and 0. And last one is 5 2s are is 10. So this is 10 plus 0 plus 24. The last one is 2 into 1 is 2. 4 into 0 is 0, and 5 2s are is 10. 2 into 0 is 0, 4 2s are 8 is 0, 5 into 0 is 0, 2 2s are 4, plus 4 plus 15. So 2 2s are 4, 4 into 1 is 4, and 5 3s are is 15. Last is 8 plus 0 plus 26, and it is 8 0 is 0, 0 2 is 0, 13 0 is 0, 8 2 is 16, 0 into 1 is 0, plus 13 into 3 is 39. And we have it's 21, 0, 34, 12, 8. It's 4 plus 4 is 8, plus 15 is 23, 34, 0, 9, 6, 15, 3, 4, 5, 55. So a cube is 21, 34, 12, 8, 23, 34, 0, 55. And now let's calculate what's given to us. So we have to find the value of a cube. So this is a cube minus 6 a squared plus 7a plus 2i, where I is the identity matrix. Let's put in the value of a cube. So a cube is 21, 0, 34, 12, 8, 23, 34, 0, 55. This is a cube minus. Let's multiply a square with 6. So this is a square. Let's multiply it with 6. So 30, 0, 8, 6 are is 48, 6 2 are is 12, 6 4s are 24, 6 5s are 30, 6 8s are 48, 0, 13 into 6 is 78. And now plus 7a plus 7 into a. So a is, so this is 7, 0, 14, 0, 7 to the 14, 7, 7 to the 14, 0, 21. This is 7a plus 2 into our identity matrix is 1. So identity matrix is 1, 0, 0, 1, 0, 0, 0, 1, and this has to be multiplied with 2, which gives us 2, 0, 0, 0, 2, 0, 0, 0, 2. Okay, let's simplify this. So 21 minus 30 is minus 9, 0. 48, 34 minus 48 is negative 4, 48 minus 4 is 4, 4 minus 8 minus 4 is 4, 4 minus 3 is 1. 12 minus 12 is 0, 8 minus 24 is negative 16, and 23 minus 30 is negative 7. So 34 minus 48 is 4, and 1 negative 14 is 0, and this is negative 8 minus 5 is 3, 7 minus 5 is 2. And this has to be subtracted from, let's add these two. So this is 9, 0, 0, 9, 0, 14. This is 9, 0, 14, and this is 0, 16, 7, 14, 0, 23. Okay, so these gets cancelled. These are all this terms with the negative signs, and this is equal to negative. This is equal to O, and hence we have shown that it's the AQ minus 6a squared plus 7a plus 2y is a null matrix. Okay, let's move on to part B, where we have to solve a system set of equations by finding inverse of the square matrix. So we are on question number 34 part B. So this is question number 34 part B. So it's given that A matrix is 3, 2, 5, negative 7. We have to find A inverse, and we know that the A inverse is equal to adjoint of A divided by determinant of A. Now adjoint of A is easy to find for a square matrix. Just swap these two numbers, that this is minus 7, 3, and give the negative signs of these two. So minus 2, minus 5. So this is adjoint of A. Now determinant of A is 3 into minus 7 is minus 21 minus 10, which is minus 31. So A inverse now is minus 1 by 31, minus 7, minus 2, minus 5, and 3. So this is A inverse. Now we have to solve the given set of equations, and given set of equations are 3x plus 5y is equal to 11, and 2x minus 7y is equal to negative 3. So these given set of equations can be written as given set of equations can be written as, we can write it as Cx is equal to D. So C, where C is 3, 5, 2, minus 7, and X is XY variables, D are the constants, 11, minus 3. And we have to find the value of X, that is XY. Now, if we check C, so C is 3, 5, 2, and negative 7. So this is the value of C. And A, we have A. So A is 3, 2, 5, negative 7. And if we find the transpose of A, that would be 3, 5, 2, negative 7. So that means C and A transpose are equal. So C is equal to A transpose. And for this equation here, we have to find X. So X is equal to C inverse D. And now C is equal to A transpose. So instead of C, I can write A transpose, because C is equal to A transpose. It's inverse D. Now transpose of inverse of the transpose is equal to A inverses transpose. So I can write this as X is equal to A inverse transpose T. Now we know the value of A inverse, so let's put in the value of A inverse. We have the value of A inverse, which is minus 1 by 31, and A inverse is minus 7 minus 2 minus 5 3, and we have to find its transpose into D. D is 11 minus 3. So X, let's put in the value of X. X has variables X and Y. So this is equal to, we can keep the constant out. So the transpose of this is minus 7 minus 5 minus 2, 3, and 11 minus 3. Let's multiply this. So this is xy, which is equal to minus 1 by 31. This is minus 77 plus 15 and minus 22 minus 9, which gives us xy is equal to minus 1 by 31. This is negative 7 minus 5 is 2, 62, and negative 31. Now let's divide it with negative minus 1 by 31, which is equal to 2 and 1. So the value of x and y, so x is equal to 2 and y is equal to 1. So this solves our question number 34, and let's move on to question number 35. So we have got solved it for the values of x and y. So x is equal to 2 and y is equal to 1. And let's move on to question number 35. Okay, for question number 35, we have to find the value of b so that the lines x minus 1 by 2 given equation of the lines are intersecting lines. Now, let's say we are on question number 35, part A. And let's say this is the first equation of the line L1, which is x minus 1 by 2 is equal to y minus y by 3 is equal to z minus 3 by 4. And the next equation of the line is L2 is x minus 4 by 5 is equal to y minus 1 by 2 is equal to z by 1. Now, so these are the intersecting lines. So we know that for the non-coplanar lines, the shortest distance between them is the shortest distance between two lines which are not intersecting is b1 cross b2 dot product with a2 minus a1 divided by the magnitude of b1 cross b2 magnitude. Now this is the shortest distance between two lines, but if the lines are intersecting, so that means this shortest distance is 0. And if this shortest distance is 0, that means b1 cross b2's dot product with a2 minus a1 should be equal to 0. So let's find out, let's use this concept. So this is b2 vector b1 cross b2 dot product with a2 minus a1 is 0. And why we have used this, because the shortest distance between two lines is given by this formula. And if the lines are intersecting, that means the shorter distance is 0. So this goes to the right hand side and we get this. So we are going to use this. And for that, let's get our A2, A1 and B1, B2. So A1 here is the position vector. So this is 1, B and 3. So this is I cap plus Bj cap plus 3k cap. This is A1 vector. Similarly, B1 vector is the from the direction ratios, that is b1 vector is a vector which is parallel to L1, line L1, and which is these are the direction ratios of that vector. So it is 2i cap plus 3j cap plus 4k cap. Now similarly here, A2 vector is 4i cap plus j cap, and we don't have the coordinates for z. So b2 vector is, this is 5, this is 5 I cap plus 2j cap plus k cap, this is 1. Now let's find out a2 minus a1 vector. So a2 is 4 I cap plus j cap minus a1 is I cap plus bj cap plus 3k cap. So 4 minus 1 is 3 I cap, and this is 1 minus b into j cap and minus 3k cap. So this is a2 minus a1. And let's find out the cross product of b1 and b2. So the cross product of b1 and b2 is ijk. b1 has the scalar components 2, 3, 4, and this is 4, 2 and 1. Okay, so b1 cross b2 is I cap, and this is 3 minus 8 minus j cap, which is 2 minus 20 plus k cap, which is 4 minus 15. And this is minus 5 I cap plus 18 j cap minus 11 k cap. Now this is b1 cross b2, and this is a2 minus a1. We have to find their dot product. So dot product of b1 cross b2 with a2 vector minus a1 vector. So this is minus 5 I cap plus 18 j cap minus 11 k cap. Dot product with 3 I cap plus 1 minus b j cap minus 3 k cap. So minus 5 into 3 is minus 15 plus 18 into 1 minus b is 18 minus 8b, so 18b minus 11 into minus 3 is plus 33. And now this should be equal to 0, so this is equal to 0 for the intersecting lines. So this gives us minus 18b is equal to minus 15 plus 18 is 3 plus 33 is 36. And when shifted to right hand side, it's negative 36. So b is equal to 2. Okay, so that means our equation of the line, the first equation of the line, L1 is, this is x minus 1 by 2 is equal to y minus b is 2 now, 3. So we can put its value z minus 3 by 4. And the second equation of line is x minus 4 by 5 is equal to y minus 1 by 2 is equal to z by 1. Okay. Now, next question is we have to find the point of intersection of these two lines. So point of intersection of these two lines means that if I point of intersection of these two lines, let's say this is the point of intersection of these two lines, which is common to both the lines L1 and L2. So if I take the coordinates of this point from line 1, that will satisfy the coordinates of the point on the line 2. So let's say this is equal to k for line 1, L1. So equating this with k gives us x is equal to k plus 1, and y minus 2 equating to 3 will gives us y is equal to 3k plus 2, and this equating will give us z is equal to 4k plus 3. So x is equal to 2k plus 1, y is equal to 3k plus 2, and z is equal to 4k plus 3. Now we will replace these values in line L2, and so replacing these values in line L2, because it's a point of intersection, so this will satisfy, these points will satisfy the equation of the line L2. So this, for x I can put it's 2k plus 1 minus 4 by 5 is equal to y is 3k plus 2 minus 1 by 2 is equal to z, is 4k plus 3 by 1. Okay, if I consider these two, it will give me the value of k. So this is 2k plus 1, and this is minus 4, which will give me minus 3 by 5, and this is 3k plus 1 by 2. If we cross multiply this, this is 4k minus 6 is equal to 15k plus 5. 4 minus 15 is minus 9k, and this is 11. So k is equal to minus 11 by 9. And we've got the value of k, which is minus 11 by 9. Uh, okay, just let me just check it once again. So x minus 1 by 2 is equal to y minus 2 by 3 is equal to z minus 3 by 4 gives us x. Since x is equal to 2k plus 1, 3k plus 2, and if you replace this value here, so this is 2k plus 1 minus 4 upon 5 is equal to 3k plus 2 minus 1 upon 2. So this is 3k minus 3 by 5 is equal to 3k plus 2 minus 1 is 1. So 4 minus 6 is equal to 5, 3, 15 plus 5 minus 9k, and 5 plus 6 is 11. Okay. Okay, so this is 2k minus 3 by 5 is equal to 3k plus 1 by 2, and if we cross multiply this, this is 4k minus 6 is equal to 5 3s are is 15 plus 5. Now 4k minus 15k is equal to 5 plus 6. Okay, which is, sorry, minus 11k. This is 11, and k is equal to negative 1. So k is equal to negative 1. So that means the point of intersection, let's replace the value of k negative 1 here. So k is negative 1. Therefore, point of intersection is x is equal to 2 into negative 1 minus 2. This is minus 1 minus 3 plus 2. Y is minus 1. And z is equal to minus 4 plus 3 is negative 1. So the point of intersection is negative 1, negative 1, and negative 1. And this solves the part A. And let's move to second part. The second part is, let me first of all erase these. Okay. Okay, for part B, question number 35, part B, we have to find the equations of all sides of the parallelogram ABCD whose vertices are given. So let's do this part first. Now rectangle is, sorry, parallelogram is ABCD. So this is A, B, C, and D. Now the coordinates of A are 4, 7, 8, and B are 2, 3, and 4. And C are, coordinates of C are negative 1, negative 2, and 1. And coordinates of D are 1, 2, and 5. So equations of all sides. So let's get the equation of CD. So CD is, okay, sorry, the first one is AB. So AB is a line passing through these 2 points, 4, 7, 8, and uh, 2, 3, 4. And we know that the equation of a line passing through 2 points is given by x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 upon z2 minus z1. So we are going to use this formula for each of these 4 sides. The first one is x minus x1 is 4 is equal to y minus y1 is equal to z minus z1. and 2 minus 4 is minus 2, 3 minus 7 is minus 4, 4 minus 8 is minus 4. So this is the equation of the line AB. Now equation of the line BC is x minus, these are x1, y1, z1, minus 2, y minus 3, z minus 4, minus 1 minus 2 is minus 3, minus 2 minus 3 is minus 5, and 1 minus 4 is minus 3. Similarly, we can get the equation of line CD. So it's x minus of minus 1 is plus 1, y minus of minus 1 is plus, minus of minus 2 is plus 2, z minus 1, and this is now for CD. Minus of minus 1 is minus 2. Okay, it says x2 minus x1, so this is 2. So this is 2. 1 minus of minus 2 minus of minus 2 is 4, and 5 minus 1 is 4. We have 2 common here, so we can take 2 common and write this equation as, this equation can be written as x minus 1 by 1 is equal to y plus 2 by 2 is equal to z minus 1 by. Okay, so this is the equation of the line CD. Similarly, we can get the equation of the line D, equation on side DA. So this is x minus 1, y minus 2, z minus 5, and 4 minus 1 is 3, y minus 2, 7 minus 2 is 5, and 8 minus 5 is 3. Okay, we have got all the equations of the sides. Now moving on to the next statement, we have to find the corners of the foot of the perpendicular from A to. So foot of the perpendicular from A to B, let's say this is the perpendicular and foot of the perpendicular is B. Now, this point P lies on CD. So foot of perpendicular P lies on CD. So that means if I equate this line CD, so equation of CD is x plus 1 by 1 is equal to y plus 2 by 2 is equal to z minus 1 by 2. So let's say this is equal to k. So this gives us x is equal to k minus 1, y is equal to 2k minus 2, and z is equal to 2k plus 1. Now, this point lies on line C. Now, let's say for some value of k, this is the foot of the perpendicular. Now, for some value of k, this is the, these are, so these are means x, y, and z, some value of k. So these are the coordinates of foot of perpendicular. So these are, let's say, coordinates of foot of perpendicular. So if these are the coordinates of the foot of the perpendicular, so that means a direction ratio. So we can find the direction ratios of AP. So direction ratios of line AP. Now AP, for AP, we have A is, the coordinates of A are 4, 7, 8, 4, 7, 8, and the coordinates of P are K minus 1, 2k minus 2, and 2k plus 1. These are the coordinates of P, and that is k minus 1, 2k minus 2, and 2k plus 1. Now the direction ratios of AP is, direction ratios of AP are given by x2 minus x1. So this is k minus 1 minus 4. It's 1 minus 4. And the next direction ratio is 2k minus 2 minus 7. So 2k minus 2 minus 7. And then 2k plus 1. So 2k plus 1 minus 8. So this gives us the direction ratios of AP, which would be k minus 5, 2k minus 9, and 2k minus 7. So k minus 5, 2k minus 9, and 2k minus 7 are the direction ratios of AP. Similarly, we can get the direction ratios of CD. So direction ratios of CD are minus 1 minus, so 1 or 1 minus 1 is 2. We can write it 2. And 2 minus of minus 2 is 4. 5 minus 1 is 4. Now, since AP is perpendicular to CD, so that means A1, A2, that is the sum of the product of their respective direction ratio should be equal to 0. So A1 is k minus 5, so it's 2 into k minus 5 plus 4 into 2k minus 9 plus 4 into 2k minus 7 should be equal to 0. So it's 2 into k minus 5 plus 4, or we can also, okay, so this is 2k minus 10 plus 8k minus 36 plus 8k minus 28 is equal to 0, which gives us 2k plus 8 is 10 plus 8 is 18 minus 10 minus 36 is minus 46, and minus 46 and minus 28 is 1474. So this is equal to 74, which gives us k is equal to 74 by 89, and this is 37. So k is 37 by 9. So the value of k is 37 by 9, so we can get the coordinates of P. So if we have to find the coordinates of P, we have to replace the value of k. So coordinates of P are, so these were the coordinates of P, x. So these were the coordinates of P. Okay, the first one was k minus 1. So k minus 1 is 37 by 9 minus 1. Second was 2k minus 2, so 2 into 37 by 9 minus 2. And the third one was 2k plus 1. So this is 2 into 37 by 9 plus 1. And the 30 coordinates are 37 minus 9. 17 minus 9 is 8. So this is 28 by 9. And this is 2 into 37 is 7 twos are 14. 2 threes are 6. 74 minus 9 by 9. This is 2 into 37 by 9. This is 7 twos are 14. 2 3 are 6. 74 plus 9 by 9, which gives us 28 by 9. 74 minus 9. 14 minus 9. Okay, this is 18. And this is 9. Okay, 14 minus 8 is 6. And 6 minus 1 is 5. So 56 by 9. And it's 83 by 9. These are the coordinates of the foot of the perpendicular: 28 by 9, 56 by 9, and 83 by 9. And this solves our question number 35. Let's move on to section E. Here we are on section E, and this section comprises of 3 case study based questions of 4 marks each. And let's get started with the case study 136. For question number 36, this is an octagonal prism, and it's a 3D polyhedron that is bounded by 2 octagonal bases. So these are the octagonal bases, one at the bottom and one at the top here, and 8 rectangular faces: 1, 2, 3, 4, 5, 6, and 8. These are rectangular faces. Now it has 24 edges and 64 vertices. Okay, now this prism is rolled along the rectangular surfaces. So this prism is rolled along these rectangular surfaces either this way or this way. And there are the numbers on the bottom face that touch the ground. and x denotes the number obtained on the bottom face. So x is the number of the rectangular face that touches the ground, and the property distribution table for this is given. Right. Now we have to find the value of the first one is we have to find the value of p. So to find the value of p, we know that the sum of all these, the probabilities of the random variables will be is always equal to 1. So p of, so the first part is that p of x is equal to 1 plus p of x is equal to 2 and p of x is equal to 3. It goes on like this till the probability of x is equal to 8 is equal to 1. So let's add the probabilities. The first one is p plus 2p plus 2p plus p plus 2p plus p square plus 2p square plus 7p square plus p. These are the properties that should be equal to 1. So 1 plus 2 is 3 plus 2, 5, 6, 7, 8, 8 and 9. So this is 9p plus 373 is 10p square is equal to 1. And now this becomes a quadratic equation. 10p square plus 9p minus 1 is equal to 0. So this is now 10p square plus, now this can be written as 10p minus p minus 1 is equal to 0. And we have common here is 10p, so this is p plus 1 minus 1 is common, which is p plus 1 is equal to 0. And this is 10p minus 1 into p plus 1, which is equal to 0, which gives us p is equal to 1 by 10 and p is equal to negative 1. So p cannot be negative 1, so value of p is 1 by 10. And let's move on to the second part. We have to find the probability of x greater than 6. So probability of x greater than 6. Okay, for part 2, we have to find the probability of x greater than 6. So x greater than 6 are 7 and 8. So this is equal to probability of x is equal to 7 plus probability of x is equal to 8. So x is equal to 7 is 2p square, and this is 7p square plus p, which is 9p square plus p, and p is 1 by 10 plus 1 by 10. So this is 9 into 1 by 100 plus 1 by 10, which is equal to 9 by 100 plus 1 by 10. LCM is 100, which is 9, and this is 10. So this is, 19 by 100. So the value is 19 by 100. Okay, now for moving on to part 3, we have to find p of x is equal to 3m, where x is a natural number. So p of x is equal to 3m, and m is a natural number. So if we put m natural number starts from 1, so if we put x, m is equal to 1, so that gives me p of x is equal to 3. And if I put m, next natural number is 2, that gives me probability of x is equal to 3 to the 6. And if I put m is equal to 3, that gives me probability of x is equal to 9, but we don't have the random variable as 9. So we will just remove this and add the probability of x is equal to 3 and x is equal to 6. So the natural number m, when put x is equal to 1, gives x is equal to 3, and m is equal to 2 gives us x is equal to 2. So for 3, the probability is 2p, and 6 is p squared. So 2p plus p squared. So this is 2p plus p square, and p is 1 by 10. So this is 1 by 10 square. This is 2 by 10 plus 1 by 100, which gives us 100. This is 20 plus, which is 21 by 100. Okay. Right. Now we have to find the mean of x. So mean of x, and this is the last part, that is the mean of x. So mean of x is denoted by e of x, and that is the sum of the product of the random variables with the respective probabilities. So it's 1 into p plus 2 into 2p plus 3 into 2p plus 4 into p plus 5 into 2p plus 6 into p square plus 7 into 2p square plus 8 into 7p square plus p. So this gives us p plus 4p plus 6p plus 4p plus 10p plus 6p square plus 14p square plus 8 7s are 56p square plus 8p. Let's add this. So this is 5 plus 6 is 11 plus 4 15 and 10 is 25. 25 and 8 is 33. So this is 33p plus 6 plus 14 is 20 and 20 plus 56 is 76. 76 p squared, and let's put in the respective value of p, which is 1 by 10. So this is 1 by 100, which gives us 33 by 10 plus 76 by 100. And when we take 100 LCM, so this is 330 plus 76. So 330 plus 76, 6, 7, 3, 10, and 4. So this is 406 by 100, which gives us 203 by 15. That is equal to 203 by 50. And this solves our question number, the first case study, question number 36. Let's move on to question number 37. For case study 2, uh, question number 37, it's given that we have to set up a rainwater harvesting system, and a tank to collect the water is to be dug. So this is the catchment area. The rain will be falling here, and from here the rain goes to the tank. So this is our tank. Now this tank has a square base and has a capacity of 250 meter cube. This is the volume of the tank. And to dug out the tank, to purchase or yes, to purchase this much land to dig out the tank, which has a square base, the cost of the land is 5,000 per square meter. And the cost of digging, it increases with the depth, and for the whole tank, the cost of digging is 40,000 x square, where h is the depth of the tank and x is the side of the square base. So this tank has a square base with side x and height h. Now, based on this above information, we have to answer the following questions. We have to find the total cost of digging in terms of x. So the total cost of digging in terms of x. So first of all, the cost of the land. Let's find out the cost of the land. So cost of the land is will be the cost of the square, because we have to dug this tank on that square piece of land, and the square has the area of square. So this is the side x, so area of the square is x square, and the per meter square, so area of the square base is x square. That has to be multiplied by 5,000, so that will give us the cost of the land. So this is 5,000 x square. Now we have to find the cost of digging, and it's given that for the whole tank the cost of digging it increases with the depth, and if h is the depth, then the cost of the digging is rupees 40,000 into h square. So this is 40,000 into h square. This is the cost of the tank, this tank, but this has to be all in terms of x. And for that is x, h has to be converted into x, and to convert this into x, we have to make use what is given in the question. It's given that the volume is 250 meter cube. So volume is 250 meter cube, and volume of the tank. This is a tank with a square base, and area is x square, height is h. So the volume is x square into h. So this is x square into h. So this is the tank with the base x square and height h. So x square into h is equal to 250, which gives me h is equal to 250 by x square. But we have to put in the value of h square. So this is 5000 into x square plus 40,000 into x square is 250 x square upon x raised power 4. So this is the cost of the tank in terms of x. Now we have to find the rate of change of cost with respect to the side of the square base of the tank. That is dc by dx. We have to differentiate this with respect to x. So differentiating this with respect to x will give us 5000 into 2 is 10,000x, plus this is 40,000 into 250 square. Now differentiation of x raised power 4 is minus 4 upon x raised power 5. So this is negative 4 upon x raised power 5, which gives us dc by dx is equal to 10,000x, and minus 4 into 4 is minus 16. So 1,60,000 into 250 square upon x raised power 5. This is dc by dx. Now we have to find the value of x for which the cost is minimum. So finding the value of x, and at that value the cost should be minimum, we have to find the second order derivative as well. So for first of all, let's find the value of x for minimum cost. dc by dx should be equal to 0. And let's put this equal to 0. So this is 10,000 into x minus 1,60,000 into 250 square upon x raised power 5 is equal to 0. So let's take LCM here. So LCM is x raised power 5. This is 10,000 x raised power 6 minus 1,60,000 into 250 square, which is equal to 0. So this shifted to this side gives it's equal to 0. So this is 10,000 x raised power 6 is equal to 1,60,000 into 250 into 250. So these four zeros gets cancelled. So x raised power 6 is now equal to, this is 16, which can be written as 2 into 2 into 2 into 2. 250 is 5 into 5 into 2 into 5 into, this is once again 5 into 5 into 2 into 5. Okay, now x raised power 6 is 2. We have 2 raised power 6 into 5 raised power 6. So x is equal to 2 into 5, which is equal to 10. So 10 unit is the cost. So sorry, 10 is the side of the square base of the tank in meters. So this is 10 meter. And we have to make sure that when it's dug for 10 meter, the cost is minimum. So that means we have to find the second order derivative. So this is the first order derivative, and let's find out the second order derivative. That would be 10,000 minus 1,60,000 250 squared. And now differentiation of x raised power 5 is negative 5, which would make it plus, and this is 5 upon x raised power 6. And this second order derivative, when x is equal to 10 is greater than 0, so that means c is minimum when x is equal to 10, because all these are positive. So the positive will give us the result greater than 0. So cost is minimum when the side of the square base is 10 meter. Okay, now let's solve the part B as well. We have to check whether the cost function expressed in terms of x is increasing or not, where x is greater than 0. So for increasing or decreasing, so this is the part 3. So part 3 is part B. So for increasing or decreasing function f dash x, for increasing or decreasing function, f dash x should be greater than equal to 0. And for this, we have to find the value of x when we have got the value of x. So let's find out the value of x. dc by dx is equal to 0. If we put dc by dx is equal to 0, we have already got the result here. So if this is dc by dx is equal to 0, which gives us x is equal to 10. So if you put dc by dx is equal to, this gives us x is equal to 10. And it's given in the question that x, for we have to check for x is greater than 0. For x is greater than 0, so this is 0 and this is 10. So our intervals are 0 to 10 and 10 to infinity. Now sine of dc by dx for 0 to 10. So dc by dx for 0 to 10, this is dc by dx. For 0 to 10, it will be less than, it will be negative. So for 0 to 10, this will be less than 0, and for 10 to infinity, this will be greater than 0. So for in this, the nature of function when it's 0 to 10. So 0 to 10, we can put in any value here. For 0 to 10, let's say other value is 5. So this gives us 10,000. So this gives us for value 5. This is now 10,000 into x is 5 raised power 6 minus this is 1,60,000 into 250 square upon this is 5 raised power 5. So this is 10,000 into 5 raised power 6. So this is 5 raised power 6. And so this value is greater than 0. So this value will be negative. So this is negative. So that means here the function is, the nature of the function for 0 to 10 is decreasing, and it's increasing when 10 to infinity. So this means that function c of x is neither increasing nor decreasing for x is greater than 0, because we have to check for x is greater than 0 and both these intervals are x is greater than 0. So here the function is decreasing, and in this interval for 10 to infinity the function is increasing, and for 0 to 10 the function is decreasing. So that means the function is neither increasing nor decreasing. And okay, so this solves our question number, the case study, that is question number 37. Let's move on to the last one. Okay, we are on to the final question, that is case study 3 and question number 38 of this set. And question number 38 says that a volleyball player serves the ball which takes a parabolic path given by the equation. So this is question number 38, and h of t is minus 7 by 2 t square plus 13 by 2 t plus 1. Now h of t, this gives the height of the ball. So this is the ball being served, and if you put the time t greater than 0, so at that instant it will give you the height of the ball at an instant. Now first is that based on the above information we have to answer the following questions. Is h of t a continuous function? Yes, because h of t is a polynomial function. This is a polynomial, and we know that polynomial function is continuous function. So h of t is a polynomial function, and the polynomial function is always continuous, though therefore h of t is it is a continuous function. Okay, now we have to find the time at which the height of the ball is maximum. So the time at which the height of the ball is maximum, that means we have to find the value of t. And for maximum height, we have to find the first order derivative, that is dh by dt should be equal to 0. So the first order derivative is minus 7 by 2 into 2d plus 13 by 2. The it should be equal to 0, which gives us minus 7t is equal to minus 13 by 2. This gets cancelled, and t is equal to, this is 2, sorry. So this is 2, 13 by 2 divided by 7, which gives us 13 by 2. And this is 1 by 7. So at 13 by 14 seconds, the height is maximum, but we have to prove that. And for that, the second order derivative should be less than 0. So let's find out the second order derivative, dh squared by dt squared, which is, this is the first order derivative, and this is the first order derivative. So the second order derivative is first order derivative. So let me write it here. So the first order derivative was minus 7 by 2 into 2t plus 13 by 2. So 2 and 2 let's cancel. This is minus 7 by t plus 13 by 2. So this is the first order derivative. Second order derivative is negative 7. Now the second order derivative, when time is equal to 13 by 14, is also negative 7, which is less than 0. So that means height is maximum when time is equal to 13 by 14 seconds. Okay, so this solves our question number 38, and with this we come to an end of this set. Do like, share, and subscribe. Thank you for watching.